Boys and girls, we are going to cover in detail a description of what are the rotary transmission mechanisms. Okay, the first thing is that they transfer motion from the driver to the driven shaft. In this case, we have friction wheels, we have gears, we have belt and pulleys, and we have chain and sprocket. Depending on the situation, we will use one system or the other. This one, friction wheels, is the most simple one. Is really cheap. Gears is when we want to transfer more power. And in both cases, you have realized the distance between the shaft es eje. The distance between the shaft is really close. Okay, and when we have a big distance, it's a good idea to use belt and pulleys or chain and sprocket. Okay, we will cover it in detail, but important. We transfer motion from the driver shaft to the driven shaft. Okay, so the first system is the one that we call friction wheels. Here we have an image of what a friction wheel consists of. In this case, we have just two wheels, one close to the other. One is going to be the driver, and the other one is going to be the driven. Depending on the situation, could be one or the other. It doesn't matter the size. Sometimes the driver is the small one, and sometimes the driver is the big one, depending on where you have the motor. Okay. Friction wheels. This is the image. Okay. Here we have direction. If you have realized, when we use friction wheels, we reverse the direction of the motion. Imagine that this one is the driver. If the driver is rotating clockwise, the driven is rotating counterclockwise. So we reverse the direction of the motion. Where do we use it? We use it when we don't need to transfer a big power. Since the mechanism for transmitting the motion is just friction, okay? So it is impossible to transfer big powers if we are using friction wheels. So we will use it just when we just need to transfer rotary motion, but with no big power. And keep this formula in your mind. We are not, I will repeat it, we are not going to use this formula, but you need to know that the different speed in the wheels depends on the diameter. The smaller the wheel, the faster the speed. Is simple. Okay. Applications, for example, and this could be one application where we transfer the rotary motion. Here also in dynamos, in all bicycles, we use this system, the friction wheel. Belt and pulley system. Okay, belt and pulley system. In this case, we are also using friction, so we use this system when we don't need to transfer a lot of power. But in this case, the distance between shafts could be big. So in case the distance between axes, between shafts, is big, it is not possible to use friction wheels, so we have to use belt and pulley. Okay, so what is a pulley? What is a pulley? It's no more than a wheel where we have a groove, donde tenemos un canal, and we have a belt that slots into the groove. Okay, so we use it for low power and distant shafts. Okay, applications for belt and pulley. For example, in washer drums, en los tambores de la nevera. Here we have, de la lavadora. In the washer drum, here we have the motor, and here is the place. This is the drum. This is the place where we place all the clothes. Okay, and machines like a drill press La traducción sería un tornillo de banco, una taladradora de banco. Okay. And a sewing machine, una máquina de coser. Okay. We use them. Okay. So chain and sprocket. Chain and sprocket is a system like this one. We use it when we need to transfer a lot of power, and we have a toothed wheel, and we use a connecting chain. Okay, it's the system of the bicycle, of motor bicycle. In those cases, we need to transfer a lot of power. Okay, again, we have a formula that is telling me that the speed of the wheel depends on the diameter. In other words, the smaller the wheel, the faster the speed has to have. Okay. Examples where we use chain and sprocket: in the bicycle, in a motor bicycle, in a lawn mower. And just the most common way for transmitting rotary motion are gears. Gears, it consists of two wheels with teeth. They rotate in opposite directions. Imagine that this one is rotating clockwise, so as a consequence, this one would be rotating counterclockwise. We use them when we want to transfer a lot of power. And one disadvantage could be that it is a little bit noisy, and we need to use oil for improving the transmission here. Okay, types of gears. According to the shape of the gear, we have three different types: spur gears, engranajes rectos; helical or helical gears, engranajes helicoidales; and bevel gears. Spur gears when the shafts are parallel. Okay, this axis is parallel to this one. If these are forming 90 degrees, we have to use bevel gears. And when we have an angle between axes that is between 0 and 90, we have to use helical gears. Okay? Engranajes rectos cuando los ejes son paralelos, engranajes cónicos cuando forman 90 grados y engranajes helicoidales cuando forman cualquier ángulo entre 0 y 90 grados. Okay, this is one example of spur gears. Es un ejemplo de engranaje recto. This one is an example of helical gears. Es un ejemplo de engranajes helicoidales. Okay. Here, pay attention here to the direction of the axis. In this case, they are not parallel, but they are also, and they are they are not crossing. Okay, so it's a very specific and particular case where the only way for transmitting the motion, the rotary motion, is by using helical gears. These are really expensive. And a particular case of gears are those that we call worm gear. Y un caso particular de engranajes son aquellos que llamamos engranajes de tornillo sin fin. En inglés la traducción sería tornillo gusano, en castellano no le llamamos tornillo gusano, le llamamos tornillo sin fin. Okay, so it consists of two toothed wheels. This one is the one that we call the worm gear. It's more similar to a screw than to a gear.
Okay, and this one is the small. It can be considered as one tooth, as a gear of only one tooth, and this one is the cogwheel. In this case, if we have 30 teeth, okay, we need to rotate the screw or the worm 30 times just to have one turn in the cogwheel. I will repeat. This one, that is smaller than this one. So this one has to rotate, in this case, 30 times in order to have a complete turn in the cogwheel. 30 times because it has 30 cogs, 30 teeth. Okay. Next one. This is one. We use the one gear. We have many applications. The most important one is when we want to reduce the speed in a system. Okay. For example, if I have a motor that is rotating at very high speed, and for any reason I want to reduce the speed, I could use a one gear. Gears applications. For example, this one is for the one gear. This one is the speed reducer, and a gearbox, la caja de cambios from a car. Okay. And we have covered motion transmission, and now we are going to cover motion conversion. We have four main systems: screw and nut, tornillo y tuerca, rack and pinion, piñón cremallera, crank link slider, que sería biela manivela, and cams, that could be levas. Okay. So let's see. Screw and nut. Okay, in this case, the rotary motion of the screw is converted into linear motion in the nut, and also works vice versa. So it is reversible. Applications for the screw and nut. This one, the one that we call vice, we have many of them in the workshop. Car jack, el gato, and a press. Okay. Rack and pinion. Okay, a rack. Piñón cremallera. The rotary motion of the pinion is converted into linear motion in the rack. El movimiento rotativo del piñón se convierte en movimiento lineal de la cremallera. Examples. We have many applications. This one, also for opening gates, and a drill press. Okay, and this one also is another example of rack and pinion. So this is the pinion, this is the rack. Okay, we use them when the slope, look here, the slope is really high. Okay, so it's a system where we use rack and pinion. Here we have the rack. Okay. Here is the rack, and the pinion is in the train. And the next one, another system where we convert rotary motion into linear motion, is this one, the crank link slider. In Spanish we will call it biela manivela. Biela manivela deslizador. Okay, so this one manivela is this one. Okay, this one is the link biela, and this one is the slider. So the rotary motion of the crank is converted into linear motion in the slider. Okay, we use this system. For example, let me see if we can open. It is not working. It is not working. Okay, I will show you the video. Examples where we use, for example, this one is an example of the crank link slider. Is a combustion engine. Okay, so we are converting the rotary motion of the crank into linear or reciprocating motion in the piston, in the slider. Okay, so the explosion that happens in the inside moves the slider downwards, and this continuous motion of moving back and forth is the one that creates here the rotary motion in a combustion engine. So here, in fact, in this image we have two examples at the same time. I'm representing here the crank link slider system, but also we are representing here a cam system, okay, where the cam is rotating and is converting the rotary motion of the cam into linear motion in the follower. These are cams, okay. Estas son las levas. It is the shape of one cam, and the rotary motion of the cam is converted into linear motion in the follower. El movimiento rotatorio de la leva, gracias a su excentricidad, se convierte en un movimiento de vaivén en el seguidor. Okay, here again we have the same picture. We have a combustion engine here, and the rotary motion of the cam is the one that is producing the opening or closing movement in the valve. El movimiento rotatorio de la leva se convierte en movimiento de vaivén en el seguidor, y este seguidor unas veces abre la válvula y otras veces la cierra. Abre la válvula y ahora la cierra. Okay? Okay, so this is the cam. It's a detailed view of the cam.